I can't, just making sure that I did this right. When if it's just the highest degree is squared, it will only be one critical number, right? And it will, if it's positive, it'll be the minimum, and if it's negative, it will be the maximum, right? And
no. So let me finish this, and when I get to that point, I'll explain with this problem, and then we'll choose another if you need to, okay? I think I got the question, so let me finish this, and when I get to that point, I'll explain. This has to be arranged in the correct order. Then I will factor out if I need to. We're not graphing, sorry. That's good enough. If we are graphing, then I have to find the x and y intercepts, but I don't need to right now. We're not graphing. So we move on to g prime of x, which is 4x to the third minus 15x squared. And yes, I have to factor out x squared. And I have 4x minus 15. So that's one of the reasons why I'm digging deep into my recycle bin for one quick comment. If I manage to find page 1, otherwise I will not be able to explain anything. So maybe page 1 was sweet and I was hungry. No, here it is. Okay, so the reason why we want to fully simplify this function and factor it is because of this. It's because of finding critical numbers. That was one very important comment that I had. So now we know that g prime of x is never undefined. It's a polynomial function. So g prime of x could be 0. If g prime of x is 0, I have to present 3 solutions. Why 3 and not 4 or 10? Because the degree is 3. So can anyone give us those solutions? This is algebra. This is a long time ago. This is not calculus.
Well, x squared equals, never mind.
You're correct. X squared equals 0. All you have to say is 2 solutions 0. Move on. Yep. What is the third solution?
15 over 4.
That's it. Perfect. That's all I needed. So now I start my table in which I put g prime of x and I put g of x, mandatory. The domain, as we discussed, is what for this function? Anyone?
Negative infinity to positive infinity.
Very good. It's a polynomial function. Very good. All I have to write is the 0 here, put 0, and 15 over 4, which is close to 4. But I have to write 15 over 4. What do I write here under those numbers in the row for g prime?
0.
Of course, 0 and 0. Now I need to find, if you want, we can do that, but there are other ways, simpler ways. But if you want, plug in a number, and I need a sign of the derivative here. You can plug in negative 10. Of course you will not plug in, don't erase anything. Of course you're not going to plug in anything in that piece. Why I will not even look at it? Why?
Because we're just inserting negative infinity and infinity.
Because it's always positive. It's x squared. No matter what you plug in here, it's not going to have any impact on anything. If it were x, I had no choice. I had to replace everywhere. But in x squared, I refuse to put in anything. It's always positive. So only here, please plug in negative 10 and tell me the sign, just the sign.
Positive.
So now plug in 1 and tell me just the sign, because 1 is between this and this.
Negative.
Good. And now tell me when you plug in 10, what is the sign?
Positive.
Perfect. Now we're going to have to plug in our function in the calculator. I'm going to share my screen. Let's do that. It's a very good question, and thank you always for asking these questions. We discover a lot from any question that comes from you. Okay, I'm sharing my screen right this moment. Where is my button? Right here. Okay, got it. So here it is. In y equals, I will plug in x to the fourth. Where is my x? X to the fourth, and then minus. Oh my goodness. Sorry. I graphed the hyperbolic functions last night with my calculus class, the other class. The regular calculus. Okay, so sorry about that. So x to the fourth, and then minus 5x cubed. Minus 5x to the third power. And now I plug in second and table. All I have to plug in is 0 and 15 divided by 4. So obviously the first one is 0, the other one is negative 65.92. Always remember to look to the right, go to the value, because the calculator will not present everything. See what's happening here? So it will round up, and you may want 3 digits, you may want 4 digits, it doesn't matter, but always highlight this number. So I got negative 65.92. Okay, I'll stop sharing now. At this point, I'm asking myself what to write here and what to write here. Extremely important. So here's our function. Which of these terms is the most powerful?
X to the fourth.
Good. So where does x to the fourth go when x approaches negative infinity?
Negative infinity. Or was it positive infinity?
Because it's power 4, right? Power 4 can never give us a negative number, correct?
Yeah.
Good. So this is positive infinity, and obviously the other side is also positive infinity. Now remember, we do not draw conclusions before we make sure that these two rows cooperate. This is the point in time where I check and I realize if I have any errors. So what does the function do between negative infinity and 0 because its derivative is negative?
Goes down.
Good. Is it true from positive infinity to 0, does it go down? See, if I had written negative infinity here, I would have said, oops, how can it go down from negative infinity to 0? Right?
Yeah.
Good. So what does the function do here? The same thing decreases. Is it true from 0 to negative 66 roughly? Is that correct?
Yes.
And what about from negative 65.92 to infinity? What does the function do?
It goes up.
Good. Only now, and here is my answer to who was asking, was it Lake or Jackson at the beginning? With a question about the sign.
Wasn't me.
Okay, Lake, was it you?
No.
So who asked about the sign? Was it Haber then?
Oh, mine was just about going from the power to the amount of critical numbers, which I think you've kind of answered.
Okay,
least I
so
think I
okay.
understand.
In any event, there is no sign change here. This point is not a point of extrema. There is a sign change here from negative to positive, from negative to positive. What type of point will be 15 over 4, comma, this number? Relative or local what?
Minimum?
Yes. Is that clear? This does not mean anything because the derivative does not change sign. It's something like this. It's always going up or always going down. There is no point of extrema. A point of extrema means a turn. A point of extrema means a turn. From positive derivative to negative derivative. From negative derivative to positive derivative. Any questions? the answer may not be accepted as a decimal. So I may have to determine g of 15 over 4 as 15 over 4 to the 4th power minus 5 times 15 over 4 to the 3rd power, and not be able to use the calculator. I don't know how MyLab Math will accept it. So I'm going to do this. So then I have 15 over 4 minus 5. And this is negative 20. So this is negative 5 over 4 times 15 to the 3rd over 64. So I may have, I'm going to use the calculator on this one. So I have 15 to the 3rd power and times 5. And I got negative, what did just happen? 15 to the 3rd power. Okay, and times 5. Okay, so negative 16875 over 256. So it may not accept the answer like this. They may want an exact answer, and then we have to enter the point of extrema, which is in this case a minimum. So it will be 15 over 4 comma negative 16875 over 256. Very good question. Was there something else? Let me see. Okay. Select the correct choice below, blah, blah, blah. Okay, so that's your answer. Is this okay, Rita?
Yeah, it was just an odd number, so.
Yeah, it is. I agree. Good. Other questions from me before we move on? Other questions? Is there anything else from 2.1 that you would like to go back to? Anything else?
Can we do number 30 from the written homework?
Yes. Which page was that? Was it from 201?
I think it was. I'm not sure though.
Remember, I will post solutions with the video and for that, but if you still want to see it, let's do it. So you said 30, right?
Yeah.
Very good. So we have g of x equals x squared divided by x plus 1. Remember, I don't want you to graph. No, not yet, right? So I think I put the information in there, correct? In which I said I only want you to find the critical numbers and max min and increasing, decreasing, right?
Yeah, you said not to graph it.
Yes.
and
No, we're not ready for that yet.
directions on-
We have more information to look at. Okay, so first of all, I will find a domain. I have to find a domain. Can anyone give us the domain of this function?
All real numbers except for -1.
Excellent, thank you very much.
Oh, but isn't it x squared plus 1 on the bottom,
Ah,
not x?
very good. Very good. Sorry. So this function is defined on everything because x squared plus 1 will never be 0. Even better. Keep an eye on what I copy. Well done. Sorry about that. Thank you for letting me know. And not letting me go through the problem and then say, oh, you forgot. Thank you. Okay, so all real numbers. I will start by finding g prime. And we have to use the quotient rule. Can anyone walk us through? Anyone would like to give us a boost here? So the top function prime, yes. Shvam, if you'd like to try, go ahead.
Would it be 1? Or don't you do the rule where you put it like 1 and then 2 square root? Or
Right, but what is 1 prime? Yes.
Is it just
So the top prime is 2x times the denominator minus the top times the denominator prime over the denominator squared. Is this what you got so far, everyone?
Yeah.
I refuse to multiply when I see that I can clean it up. You already know a little bit about me. As a friend of mine said, I told you. She says we are running a clean ship. So 2x comes out, and then I have x squared plus 1 minus x squared. Very nice. So the simplified form is 2x over x squared plus 1 squared. Critical numbers come from two possible sources. G prime being undefined. Not the case here. Because x squared plus 1 is always non-zero. This will always exist. But G prime could be 0. So what do we get when a fraction is set equal to 0? How do we get this? Gabby, will you tell us how?
Setting the top equal to 0.
Good, very good. Thank you very much. So x equals 0. So the only critical number, which is the critical number, the only one, is right here, 0. I have to write 0 here. I have to study the sign, and I have to plug in 0 here. 0 over 1, 0. Then we will determine these limits in a minute, but I would like to study the sign of the derivative first. So this is the derivative function. Which piece of this is redundant? I'm not going to waste time on it when I need to find its sign. I refuse to plug in anything in one piece from this function. Which piece?
The squared one.
Exactly. Don't waste your time. The sign is given by x. So tell me the sign of this expression to the left of 0 and to the right of 0.
Negative, then positive.
This is typical for what type of point? A max or a min?
Min.
Very good, indeed. So this is the relative min. It could also be an absolute, which means the one that is the smallest. Relative min, 0, 0. Not 0, 0. This is the derivative. It's 0, 0. Now I would like to determine these limits because I need them in this class and the next class anyway. So let's determine the limits here. Good. So I want to find the limit as x approaches negative infinity from x squared over x squared plus 1. And also when x approaches infinity, it's not going to make any difference, so I'm not going to write it twice. When we determine a limit, what is the first thing we need to do?
plug in x?
Yes, not x, but plug in this, whatever that is. That is the first point. Excellent, yes. So then, can you tell me where the top is going and where the denominator is going? Where is the numerator going?
Infinity.
Very good. Where is the denominator going?
Also infinity.
Infinity.